To do arithmetic, we need to keep in mind the following rules when working with signed numbers. That if we have two signed numbers, this is going to be a positive and this is a negative, then plus and a minus, really A can be either positive or negative, but here we're saying that B is negative. A plus or a minus right next to each other, or here we're going to subtract a positive number from A. That if we have one of each, then we can change these to just being a minus sign. Alternatively, if we have two of the same signs right next to each other, A can be either positive or negative, and then we have two pluses where B is positive here. Or if we're subtracting a negative B, then these two signs can be reduced to be just a positive. So if you have two different signs, they become a negative, and two of the same signs, they become a positive. And again, for this case, we're only looking at addition and subtraction. And so the two signs have to be right next to each other. The parenthesis is just there to clarify what we're looking at. You can kind of ignore the parenthesis in this case. So for instance, here we have two pluses, and that's going to become just a plus. Here we have two different signs, and that's going to become just a minus. Here we have two the same, that'll become a plus. And here we have two different signs, that'll become a minus. This one and this one, right, there's only one sign here. One, in this case, it's addition. In this case, it's subtraction. There's only one sign there. Here we have two different signs, that'll become a minus. In this case, we have two of the same signs, that'll become a plus. And here we have, this is two different signs, that'll become a minus. Okay, and actually doing it, doing the addition and subtraction, a number line can help visualize the answer. And it's easiest to use the number line when you replace the two signs with a single one. So in this case, we have -5 plus 8. And so how this works in the number line is you just draw a number line. This first number is your starting value, and this is going to be the direction you go. As we've talked about before, this is the more positive side of the number line. As you go that way, you will eventually get to the positive numbers. And as you go this way, you get to the negative numbers. So -5 is down here. And we're going to face the positive direction. So we're going to go right 8 units. So from this point, we're going to go right 8 units. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be -4, -3, -2, -1, 0. 1, 2, 3. So this is plus 8 units. So the answer to this is going to be 3 because we've moved 8 units in the positive direction. Okay, this one here, two different signs, that's going to become a minus. This is going to be -35 minus 20. So once again, we're going to start start at the first number, which is going to be -35 in this case. I'm going to put it over here because we're going to go left towards the negative direction of the number line. We go left. We're going to go left 20 units. Now, instead of counting out 20 units, I'm going to count by fives. It's going to be faster. So we have 5, 10, 15, 20 units down. That's going to be 5 units down this way is going to be -40, then -45, -50, and finally -55. So this is -20 units. Of course, that's going to be -55 as our solution. For this one here, we're going to have 8 plus 3 plus 4. This becomes a -3. And then finally -2. So there's multiple jumps that we have to go here. So we're going to do it like this, and I'm going to draw it like here. We're going to start at 8. Then we're going to go up 3 units. 1, 2, 3. That's plus 3. Then we're going to go up 4 more. 1, 2, 3, 4. Then we're going to go down 3. Let's do this in a minus. So 1, 2, 3 units. Then we're going to go down 2 more. So 1, 2 units there. So as we added 3, we went up to 9, 10, 11. Then we added 4 more. We're going to go 11, 12, 13, 14, 15. Then we went down 3, 1, 2, 3. So it was 15, 14, 13, 12. And then down 2 more, 11, 10. Of course, we can just go 8, 9, 10. We can see that that's where we stopped. And the overall answer is just 10. Okay, for this one, we have negative 1/4 minus 2. This is the same thing as saying negative 0.25 minus 2. Either way you do it, you can just draw out a number line like this. It's going to be a little bit harder to show on a number line because we're talking about decimal numbers, and it's not as easy to see as these integer numbers are. But we can still do it, right? Negative 1/4 is going to be the starting place. So we're going to go left. I'm going to start here. We'll do it as 0, 1, 2, and then 3. So negative 1/4 is going to be right here. It's going to be 1/2, and 1/4 is halfway that way. So negative 1/4. And from this point, we're going to go down 2 units. So down 1 unit from a fourth is going to be here to negative 1 1/4. And then down 2 more is going to go down to there. This is going to be negative 2 1/4. That is minus 2 units. So the answer is going to end up being negative 2 1/4 or negative 2.25. And what I want to show here is that when these two numbers are negative, so we have a negative 1/4 and we're subtracting off another number, really what we're doing here is we're adding these two numbers together. 2 plus 0.25 is 2.25. And because they're both negative, it's going to become more negative. Just like if I had 3 plus 2, both of these are positive. 3 is positive, 2 is positive. And so 3 plus 2 becomes more positive 5. We add them up and we get more positive. If you have different signs, like for instance, like we had here, negative 5 and 8, we actually had to subtract these numbers. This is the same thing as saying 8 minus 5. I can flip them around because of a property called commutativity of addition. 8 minus 5, we have to subtract the two numbers. That gives us 3. Just like here. Here we had two numbers that are both the same sign. We added them up. And here we had a bunch of different signs, right? This was 8 plus 3 that got more. Plus 4, they got even more. But now we had a minus 3. A positive number here and a minus number there. We had to subtract. That's the idea you should keep in mind. So this one right here, we have a negative 2 3/4 plus 1/4. We're going to start in the negative 2 3/4 portion. Be like right here. So I should have like right here is negative 3, and this is going to be negative 2. So it's going to be 2 3/4 up, and then we're going to add on to that a fourth. Well, that means we're going to go to the right direction by 1/4. 1/4 goes right here. That's going to be negative 2 1/2. So you can see what we did is we had different signs. So we end up subtracting the two numbers. 2 3/4 minus a fourth. Well, we have 3/4 and a fourth. Subtract those and we get 2/4. Negative 2 2/4. But negative 2 2/4 is the same thing as negative 2 1/2. Which is what we got right there. This was plus 1/4. Different signs means you subtract, and the same sign means you add. That's only after you do this whole process here in the beginning. You have to have a single sign between the numbers in order to keep that, use that philosophy of addition and subtraction of signed numbers. Okay, finally we have a negative 20 minus 20 minus 10. So that just becomes a minus there. Okay, these are all negative, so we're actually going to add these all up. 20 plus 20 plus 10 is 50, and it's going to be negative 50. You can, of course, do this on a number line. We're going to start negative 20. We're going to go left 20 units, so 10, 20. It's going to be negative 40. And we're going to go left 10 more units. That's minus 10. So once again, we added these up to get 50, and then they're all negative, so it's going to be negative 50. Okay, this chart shows the results of a 6-week exercise program that 5 people had taken part of. Okay, first off, sometimes when you have charts like this, it can help to have totals, and we're just going to total across the rows and then total down the columns. So here we have plus 2, plus 3, that's going to be plus 5, plus 0 doesn't change anything, and then we're going to have minus 2. So literally what I'm doing here is just going plus 2 plus 3 plus 0 plus negative 2 plus a negative 1 and then plus a 0. I'm doing the sum total of all of these numbers. But how the operations work, this is really just 2 plus 3 plus nothing, so there's no reason to write that. And this 2 signs next to each other becomes a minus, minus 2, minus 1, and then 0 again. So 2 plus 3 minus 2 plus 1. The 2 and the minus 2 cancel because 2 minus 2 is 0, so no reason to write it. We really had to have 3 minus 1 is 2. You can, of course, just plug this into a calculator, go 2 plus 3 plus 0 minus 2 minus 1 plus 0, and you get 2. I should say plus 2 as a total. The pluses and minuses are going to be important for this case because plus means weight gain and minus means weight loss. Okay, same idea here. Minus 2, minus 2, minus 2 is going to be minus 6. Minus 3 is going to be minus 9. Minus 2 is going to be minus 11. And then minus 2 more is minus 13. Minus 2 is minus 3. Nothing there. Minus 4. Nothing there. Minus 5 in total. We have 1, 2, 3, 4, 5, and they're all negative. So it's going to be minus 5. Here we have minus 4, minus 2, minus 3. It's going to be minus 6. Then minus 9, minus 11, 12, minus 13 here. Then plus 2 plus 1 is plus 3. Minus 1 is 2. Minus 1 is 1. Minus 1 is 0. And minus 1 is minus 1. Okay, that was going across the rows. Now we're going to go down the columns. 2 minus 2 is 0. Minus 1 minus 4, that's going to be minus 5. Plus 2 is minus 3. How I would do this is I'd see 3 and 1, that's going to be positive 4. And minus 2 is also going to be negative 4. Positive 4 and a negative 4 cancel. And that leaves us only with a single negative 2 remaining. Okay, here nothing cancels. We have 2, 3, and 1. They're all negative here, so we're going to add them up. 2, 3, and 1 is 6. 2 plus 3 is 5, plus 1 is 6. They're all negative, so it's going to be negative 6. Okay, in this one, I have 2 and 3 is 5. 1, 2, and 1 is 4. 1 and 2 is 3, plus 1 is 4. So 5 and 4 is 9. And of course, they're all negative, so we're going to have a minus 9 there. Okay, this one I have 1, 2 is 3, 4, 5. 5 total. And they're all negative, so we're going to be negative 5. And finally, 2, 3, 4, 5, negative 5 here. Okay, so there's the totals of each column. And of course, we can go down all the way across to get the grand total of the weight loss and gained. That's not really necessary for what we're doing here, but a lot of times you will actually do that. If you add going down this way and you add going across this way, they should be the exact same number. But that's not going to be really helpful for what we're doing here. So first off, which week, that's going to be the columns, which week had the greatest weight loss? So that's going to be the biggest negative number or the least number in the list. Of course, the least number is going to be negative 9. That was week 4. Which week had the greatest weight gain, if anything? There were no weeks of weight gain. All of them had only weight loss, so there's none. Now, which person lost the most weight in total? So lost the most weight in total, that actually is tied between Frank and Sarah. Both of them have minus 13. So Frank and Sarah. And then which one had the least weight gain, or lost the most weight? So the least weight lost the least weight, which actually would be Bill, because he actually gained weight. So Bill lost the least because he gained some. He was the only one to gain weight over this entirety, the entire 6-week period. Okay, what was the average weight change per week for each person? So there are 6 weeks, and each person had a different weight change, right? And that is shown here by these totals. So over the entire 6-week period, Bill gained 2 pounds. So on average, he gained in this case positive 2 pounds over the 6 weeks total. This would be weight gained per week. There's 6 weeks, so just divide that out, and you can see we get a positive 1/3 pounds per week. So he actually gained weight each week when you do the average weight change. It's a unit rate for this case. So that was Bill. Frank is next. Frank lost 13 pounds over 6 weeks. So that's going to be, let's get a decimal average for that one. It's going to be negative 2.17 pounds per week. All right. And now we have Jillian. Jillian lost 5 pounds for the entire time, and then 5 pounds over the 6 weeks. That's going to be negative 0.83 pounds per week. So this was Bill, Frank, Jillian. Sarah lost the same as Frank, actually. So she lost 13 pounds over the 6 weeks. So this is actually going to be both Frank and Sarah. Then we have Raj. Raj lost 1 pound over 6 weeks. And that is negative 0.17 approximately pounds per week. So that's the average weight loss, or in Bill's case, weight gain per week for this situation. All right, an airplane reached a cruising altitude of 34,000 feet. Over the next 4 hours due to weather, the plane descended to 32,000, then rose to 35, descended to 30, and rose finally to 36,000 feet. Find the total elevation change during this time. So all we really need to do here is figure out how much did the plane descend or ascend since the beginning. So, and they started at 34,000 feet, and then they descended to 32,000 feet. That means they went down 2,000 feet. Then they went from 32,000 up to 35. That means they ascended or rose 3,000 feet to get back up to 35,000. Then they descended to 30,000. They've gone down 5,000 feet. Then they've rose to 36,000 feet. So they went from 30 to 36. That's a plus 6,000 feet. So in total, we can just add those up. This is going to be positive 1,000 minus 4,000, then plus 6 is going to be in total a plus 2,000 feet elevation change. Now, what's interesting about this problem is because we know the starting altitude and the ending altitude, we didn't actually have to go through this process. All we really had to do was do final minus initial, and that gave us the change in altitude, the exact same thing. So different ways of thinking about it. There's different situations where you'd use each one. In this case, there's no reason to do this first method. This one is really a lot quicker. All right, Ryan has an outstanding credit card balance of $2,312.43 in a month. He charges an additional $324.56. and then he makes a $425 payment on the card. At the end of the month, he gets charged an additional $43.12 in interest on his balance. So what's his new balance and the APR on the card? So first off, we need to figure out what's his balance before interest. That's going to be important for the APR. So really, in a credit card balance is a negative amount. It's how much you owe. And then he charges more money on it, so he actually loses more money. And on this account, he makes a payment, and that's going to be a payment that's being gained onto there. It's actually going to oppose the debt owed. So that's going to be a plus in this case. You can of course flip these signs. You could do plus, plus, and minus here. It all depends on how you interpret the problem. Since we're talking about a debt here, that's the reason why I'm choosing to make the credit card balance a negative amount. But it makes sense as long as you understand how you're interpreting the problem. Okay, this is going to give us the balance before the interest. I am getting a before interest balance of $2,211.99. And of course, we need to add on interest to this. That's going to be an additional negative because he's going to owe that. So that gives us a final monthly balance of $22.55 and 11 cents that he owes now. Okay, now what is APR on the card? Now APR is the annual percentage rate, and this is typically calculated. I think they use daily amounts to calculate the interest. And here we only have the monthly interest, so this is the only number we can use to give an estimation from. It's probably not going to be perfectly accurate because they probably use daily amounts, but it's going to give us a pretty close estimation. So what this is saying is that if he kept this balance on the credit card for the entire year, then he would have to pay this much every single month. So in total, what that is per year, since this is an annual percentage rate, we have to figure out what's the yearly interest. We just need to multiply this by 12, since this is a monthly, the yearly. So 43.12 times 12 gives us $517.44. So this is the interest he would have to pay if he kept it at $22.11.99. That means he's paying off that $43.12 every single month, but not doing anything else with the card. So to find the annual percentage rate, all we have to do is figure out the part, which is going to be the interest rate, and divide it by the total that the interest is calculated on, which is this number here, $22.11.99. I'm not worried about the signs here because we're not concerned about being positive or negative. You could think of this as a negative interest because that's how much he's going to owe. And this is also a negative interest for owing. And so that ends up being positive. Doesn't really matter in this case. What we get is, as a percentage, 23.39. And this is actually approximately, I rounded it there. And that tends to be, that's about average. I think between 19 and 29% is a annual percentage rate for a credit card, which is extremely high. It's quite a terrible investment for what it is if you're not paying it off every single month. Okay, net worth is an evaluation of how much a person is worth, if you want to think of it in terms of what they own. Net worth is really just the sum total of assets and liabilities, and it works the same for both persons and businesses. Assets are positive values, and they include things that you own, and these are categories like real estate, so like a house that you have. If it's a business, any property that they own, things like that. Vehicles, this would be a car, or maybe a forklift, maybe different kinds of trucks, things like that. Equipment is going to be things like machinery, and maybe tools that you own, things like that. Cash held, of course, would be money in your checking account or cash being held by a business in their own account. Anything like that that you own or have held onto is just, those are all assets. Liabilities generally are just debts, things that you owe other people. Typically, that's going to be like a loan or a mortgage, or you could think of taxes being debts, maybe unpaid payments, which is just what a debt is. It's just really debts in general. So to find the net worth, we just add up all the assets and subtract off all the liabilities. Okay, so we have a home that's worth $320,000. This is going to be a plus. And a mortgage, this is a loan, this is what's owed, of $180,000. So we're going to add a minus $180,000. We could do it like this. A car that's worth $23,000. And a loan on the car that remains going to be a negative $5,000. A retirement account that's evaluated at $140,000. And then we have $15,000 in cash. It's like in a checking account and savings account. Okay, what is the net worth with just considering these things here? Well, this of course is going to be a minus, that's a plus, that's a minus, plus, plus. Really, we're just going to do this number minus this, plus this, minus this, plus this, plus this. It's just subtract off the debts and add up the assets. So doing that, I'm getting a total of $313,000. So the net worth is $313,000. And if we were to get rid of this thing, right, that would be just pretty much a straight up addition of $180,000. Same thing with this. This would be an additional $5,000 if we got out of debt. That's what we're going to be looking at next here. We're going to say, suppose you pay off your mortgage and car loan in 7 years. Homes will always appreciate over a period of time. There's only very select times where they won't appreciate, but real estate tends to always appreciate. And if you look over a long period of time, it's about 7% per year. And we're assuming that the retirement gain 10% per year. It's not appreciation, it's actually a growth. You can kind of think of it like appreciation. It works the same way mathematically, but it's like the growing of the stocks that you have in your retirement account. Your car depreciates about 16 per year. That's kind of average. And then we go from $15,000 of cash available to $30,000. So what is the net worth now? Well, the mortgage and the loan from the car are no longer there. So there's no minuses actually. We have to figure out what is the appreciation of the home though. So 7% per year means that this is a percent increase every single year by 7%. Well, if we go from 100% by a percentage increase by 7%, that means we have 107% per year every year. The same thing works for the retirement. It's going to be 100% plus 10%. So it's going to be 110% per year every single one of these 7 years. The car depreciates, however, so it's going to be 100% minus 16%. It's going to be actually 84%. So it actually goes down in value every single year. Okay, how appreciation works mathematically speaking is that if we started at $320,000 for the home, and that means we're going to percentage increase. We're going to figure out what percent or what is 107% of $320,000. And that will give us the increase amount for the first year. But then the next year, this appreciates further. Well, this is going to be the amount for the first year. The next year is going to be this amount because it's going to increase by another 7% on average. But in the next year is going to increase by this amount. And then this amount for the next year. And then this amount for the next year. And so in total, we're going to have 1, 2, 3, 4, 5, 6, 7. We're going to have 7 years because 7 years have passed. And we have repeated multiplication here. repeating multiplication is exponentiation. So really what we're doing here is we're taking $320,000 and multiplying it by 1.07 to the power of however many years it appreciates. In this case, 7 years. The same thing works. The exact same process works for the retirement account. The retirement account started at it was 140,000. And that is, I should do it like this. That's going to appreciate by 110% every year for 7 years. Now, likewise, the car depreciates. So instead of 1.07, right, this becomes 0.84. There's like, two spaces back this way, 1.07, 1.10. This is going to be 0.84. So the car is actually depreciation in the same fashion. It's going to be 0.84 to the power of 7. And that will actually show the car value going down every single year. Finally, the last thing we have here is 30,000 in cash. So we're just going to add on to this 30,000. Okay, now we can add up those things up, right? Order of operations says we need to do exponents first. So let me go ahead and do that actually. Okay, and this is what we have. We have this number here to the 7th power becomes 1.6058. In other words, it's gained 60%, about approximately 60% onto its value. Here, 1.10 to the 7th power, it almost doubles actually. It almost gains 100%. This is 94, about 95%. Here, this one, it lost pretty much 70% of its value over those 7 years. And then the 30,000, of course, stay the same. Now, we're not including inflation in this, but inflation doesn't change the dollar amount. It just changes the dollar's value when you use it. Finally, we can just do the multiplication and add up those numbers. So I'm going to do that all in one step. I'm just going to go ahead and multiply these and add up all of the numbers straight across to get our final net worth value. And I am getting approximately 823. Well, this one's not approximately, but I did round these numbers here. So this is approximately what our net worth is after all this stuff. You can see that we went from 313 to 823. It's pretty much a $500,000 increase. And the main things we did in that time was pay off the debts and let the home and the retirement increase in value just what it does naturally. We didn't even do anything really for that money to change. The car, even with the car depreciating, right? The car lost most of its value. Even though we paid off the loan, it still lost more value over the period of time. And the money, even though the money increased by 15,000, both of these things have very, very little effect on your net worth. Real estate and retirement accounts, any kind of thing that uses like mutual funds and stocks, that's the easiest way to get into it. Those things gain you a lot more money in the long run